Okay, so when we're looking at chain rule, okay, and this is just the first day we're going to do chain rule. We're going to also do this tomorrow. Okay, all of these problems over here, we already know how to do them without chain rule. These are all just power rule or basic trig. Look at what changes when we put a square root around a binomial. Notice that we know how to take square root of x, but I don't know how to take square root of a function. Again, I know how to take derivative of sine x, but I don't know how to take sine of another function like 6x, or in this case, tan x squared. Again, I know how to deal with 3x plus 2, and I know how to deal with the power, but at the same time, that gets a little bit more complicated. So right here, I've written the two main ways to do chain rule, these formulas. If you can follow me on this whole M&M thing, though, you don't need to memorize the formula, okay? There tends to be a lot of formulas. It's easy to get them mixed up. So I want you to imagine that we have a green M&M, and the f function is the shell, okay? And then I'll just use red for the end part. Like, that's pretty close to brown for chocolate. Okay, so the shell is the f function, the outer part. The inner function, g of x, that's the chocolate. So I want you to notice what happened. Okay, if I try to do derivative, I take the derivative of the outer function. This is like when we have the M&M in our mouth and the shell melts. Melting in this case is like differentiating, taking the derivative. Look what happened, though, with the chocolate, the inside part. It stays the exact same initially. Then, though, you multiply by the derivative of the chocolate. Another way to think of this is if you have a function of another function, f of u, we have f prime of u, so we take the derivative of f of x, then we take the derivative of u. Okay, both of these are ones that you could see on a textbook or a teacher in college teaching calculus. It would just depend on the notation they like. Okay, so let's just start with some examples. And again, I want to go back to the whole M&M thing. All right, so if I have a green M&M and I put this M&M in my mouth, okay, there's a shell and there's a chocolate. All right, which part of this is the shell, the outer function? Yeah, the whole thing to the fourth power. The inside part, that's the chocolate. And so you can write this on here if you'd like. So to do h prime of x, what we are going to do is we're going to melt the shell. So again, if you want to take an M&M and put it in your mouth, I put this in my mouth, and the shell melts. So I take the derivative of the something to the fourth power. So that's going to bring 4 times whatever's in front. It's going to keep the inside the same, because remember, the shell is melting, but the chocolate is not initially. Right now, the M&M in my mouth, the shell is melting, but I do not taste chocolate yet. All right? Then, as time passes, so I'm going to multiply, then the chocolate melts. So what's the derivative of the chocolate in this problem? What's the derivative of the inner function? What's the derivative of 5x plus 2? Just 5. Okay, and that's our answer. Now, if this were like, say, a book problem, probably they would multiply the 4 and the 5 together to make 20. We're not going to focus on that today, but I want you to know, like when you do your assignment in the book, they're going to have it simplified. All right, so now we get to problem 2. I can rewrite this as something to the 1/2 power. Again, you have to think, we'll just say this is a blue M&M. That's the shell. The inside part is the chocolate. Now, I'm not going to write that every time, but I want you to see the outer and the inner. Everybody knows what an M&M is like, so it makes it a little bit more tangible. So first you derive the shell. So 1/2 comes down in front. And what happens to the inside initially? It stays the exact same. So x cubed minus 2 does not change yet. What's going to be the new power? It's plus 2. Oh, I just can't see. Thank you. What's the new power? negative 1/2. Then times, and now you get to take the derivative of the inside. So 3x squared. Oop, running out of room here. Okay, that's fun. All right, so 3x squared. Let me clean that up. There's a little delay on that. Okay. All right, so far so good. It's kind of weird. I know that it's just one more thing, but okay, so look at number 3. This is a trig problem. This is a problem you really need to know how to do. Which is the shell? The cosine or the 6x? What do you think? The cosine is going to be the shell, okay, the cosine. The chocolate tends to be in parentheses. It's the inside part. So when I go to do this problem, h prime of x, I melt the shell first. Melting again in this analogy using the M&M is taking the derivative. So what's the derivative of cosine? Negative sign. So remember, keep the chocolate the same initially. That's where most students go wrong. They try to take the derivative again. Okay, times. Now you get to take the derivative of the chocolate, which is just 6. Derivative of 6x is 6. Okay, number 4. It's a similar problem, all right, but we have a different chocolate. So let's just see. I'm going to have you guys tell me what's the derivative of cosecant.
Negative cosecant.
Okay, so negative cosecant cotangent. So watch what I'm going to write here. This may surprise you. Negative cosecant x squared cotangent x squared. Remember, this is not x, it's x squared, so I have to write it in both places. Then I have to multiply by the derivative of x squared, which is 2x. So this can get overwhelming when you look at a problem as a whole, but when you look at it piece by piece, you can do it. If you don't have your trig stuff memorized, you need to do that though. That's only going to make your life easier and less stressful. Okay, so number 5. Is this cosine times sine? Okay, so if this was cosine, that's okay, this is why I'm asking it, okay? If this was cosine times sine, it would be cosine x times sine x. Let me write this down here. This, or even if I didn't write the times, this would be implied multiply. But see how there's no x right there? That means I'm actually taking cosine of sine. All right, now I'm going to write this here. Cosine of sine x. This is a chain rule problem, okay? This means that I have a shell and a chocolate, an outside and an inside function. So we start by taking the derivative of the outside function, which is what? Negative sine. And since it's cosine of sine x, the derivative would be negative sine of sine x. Remember, the inside part stays the same initially. Then you multiply by the derivative of the inside. So the derivative of the inside sine x would be cosine x. If you're thinking this was a lot easier up here, now it's getting more difficult, it could be because I'm not writing shell and chocolate on the problem. That may be something you want to do. All right, before today, how could we do number 6? We would have done quotient rule. And we could do quotient rule here. There's nothing wrong with that. But I want to show you something. If I rewrite this as 2x plus 1 to the negative 1 power. See, these are the same thing. I can, and I'm just going to move this down here, I can solve this derivative by using chain rule, and it's actually easier. But you had to know to rewrite it. So with chain rule, again, I would move the -1 to the front. I would multiply it by whatever is in front, which there's just a 1, so -1. I would keep the inside the same. I would subtract 1 from the power, which would make -2. And then I would go times the derivative of the inside. What's the derivative of the inside? 2. And that is your answer. By the way, if one of you did this using quotient rule, your answer would look a little bit different than mine. But do you know how you'd always put over denominator squared? See, this denominator to -2 is the same as squared in the denominator. They end up being the same thing, just look different. They're simplified differently. Okay, what I want you to do is 7, 8, and 9 on your own. All right, let's go over these. So what did you do first on number 7? What did you do with the square root sign? You got to change that to be to the 1/2 power. So then h prime of x, if you use chain rule, 1/2 here, that's the shell. Keep the inside the same. The new power should be -1/2. Then you go times the derivative of the inside, which should be 9x squared minus 2. And that's your answer. Okay, I'm going to work number 8 down here. What's the derivative of secant? Secant tangent. So what we got to do is say secant 3x, tangent 3x, both places. Then times the derivative of 3x, which is 3. All right, 9 was kind of weird. You might not have had enough time to work through 9, but there's one thing that will make this easier. So I'm going to actually rewrite the problem. How can I decide, say, okay, we have this 4 and we have this radical 3. What if I want to put that into a single power? What would the power be? 4/3. So the power 4 would be the numerator, and the root 3 would be the denominator. What you don't want to do here is put this to the 4th and then put the whole thing to the 1/3. That's not wrong, but it causes you to have a function within a function within a function, which is a peanut M&M, not a regular M&M, and we are going to do that tomorrow, but not today. All right, so f prime of x. You move the 4/3, multiply it to anything there is in the front, which there's not. All right, and then subtract 1 from the power. That makes that a 1/3 times the derivative of the inside. So you guys see now why we kind of had a test midway through. I wanted you to be really, really good at power rule and all that before we started with this chain rule. Okay? So now we get to combine them all together. Yay! Right? Okay, so number 10. First thing is I'm going to split this up into 2 things, and I'm going to make that square root become the 1/2 power. This is definitely a product rule problem. So, just as a reminder, with product rule, you start by taking the derivative of the first item. Then you just write the second item. Plus, I'm kind of creeping over here into 11 space, that's okay. Then you just write the first item times the derivative of the second item. This is where you're going to have to use chain rule. Okay, y'all want me to back up? Let me back up to here. Okay, let me repeat what I said. Derivative of the first item, derivative of 2x is 2, then you just write the second one. That's product rule. Plus, now I'm going to switch which one I take derivative of. So then I get to just write 2x. So what I have left is to take the derivative of this. I have to use chain rule to do that. So let me just leave this in red to make it even easier. Chain rule says multiply the 1/2 to the front, keep the inside the same. Subtract 1 from the power, so 1/2 minus 1 is -1/2. And then derivative of x cubed plus 2 is 3x squared. So overall, it can be very overwhelming. But if you just take it a piece at a time, you can do it. Okay, so all of this was number 10, okay? So I'm going to work 11 down here. So what type of rule am I going to need for 11? Quotient. So h prime of x, if I'm going to need quotient rule, I'm going to go ahead and write the big fraction bar. And several of you forgot the denominator. If that was you, maybe you need to write the denominator just like at the very beginning. Okay, so to start quotient rule, I have to take the derivative of the numerator. This is the chain rule part. This is the new stuff. So derivative of cosine 6x. Derivative of cosine is going to be negative sign. So I'm going to leave the 6x alone. Then I'm going to go times 6. Okay, everything that I just wrote, that's the derivative of cosine of 6x. So I'm going to multiply that by just regular old 2x squared minus, for quotient rule, I feel like I might run out of room here. So then I'm just going to write cosine 6x. And right there should be the derivative of 2x squared, which would be 4x. That should have gone up there in the numerator. So again, if you're kind of not sure about product and quotient rule, this is probably really overwhelming to you. It's probably a little overwhelming anyway. But we're just going to keep practicing, keep practicing, keep practicing. Okay, number 12. First thing is, I need to rewrite this as x to the 1/2 power. You gotta always, if you have a square root sign, you gotta always rewrite it. Okay, h prime of x, product rule, right? So this means take derivative of the first thing. That's gonna be 1/2 x to the negative 1/2. Then just write the second thing. 5x plus 2 to the 4th power. Plus. Then just write the first thing, no derivative, times, then you do the derivative of the second item. Okay, this is where you have to use chain rule. So I'm going to put this in blue. 4 parentheses, 5x plus 2, new power would go down by 1, so that's 3, times the derivative of the inside, which is 5. Okay, I know the answers to these are super long. Part of it is I'm writing really big up here. But just take it one piece at a time. Okay?
Where does that 5 come from at the end?
So we took the derivative of the shell, the 4. We kept the chocolate, the 5x plus 2 alone. Then, though, the chocolate's got to melt at some point, so you got to take the derivative of the inside.
Okay.